we want to show how to prove something by induction. To prove something out by induction, we need two basic steps. The first step is to prove that the first case, or normally for n is equal to 1, the statement or whatever you've been given is true. And then you go to the inductive step. In the inductive step, you make an assumption. So you have, that's called the induction hypothesis. You make an assumption that it is true for n is equal to k. Then you show that n is equal to k plus 1 is also true. Now we have been given this 1 plus 2 plus up to plus n is equal to n into brackets n plus 1 divided by 2. We want to prove that this is true. So what we need to do is first to prove, use the base case. So let's look at the base case. We want to prove that n is equal to 1. So for n, oh, maybe I changed the color of the pen so it's visible. So we have n, when n is equal to 1, we want to see whether it will hold. So when n is equal to 1, we have just 1 here, because, and then this will be equal to, n is 1, so we have 1 into brackets 1 plus 1 divided by 2. And this gives us 2 divided by 2, and which is equal to 1. So this, when n is equal to 1, the statement is true. Now the next step is to go to the inductive step and assume it is true for n is equal to k. So we assume that when n is equal to k, this statement holds. The left hand side is equal to the right hand side. So this is just an assumption, it's not something. So it's normally called the induction hypothesis. It's nothing which has been proven. So let's put it here. We assume n is equal to k holds or is true. So we have 1 plus 2 plus, now n is equal to k, so we have k is equal to k into brackets k plus 1 divided by 2. So this is an assumption. Now then what we have to do is that we want to show that when n is equal to k plus 1, this is also true. We've shown in this case, the first step, the base case, we showed that this was true when n was 1. Now we made an assumption, and now we are going to show that n equal to k plus 1 is also true for this statement or equation here. So let's go on and show that we have 1 plus 2 plus, now we have n, so n is equal to k plus 1, so we can write k plus 1, and we know before k plus 1 there will be k, so write it there. I wrote that there because I want to use this expression to do my proof. So I have this is equal to k k plus 1 into brackets. I put this as well into brackets, maybe. K plus 1 plus 1 divided by 2. Now, if you look closely, you will see that this here, 1 plus 2 up to k, is this here. So I can also, since this is equal to this, I can put this here and I wouldn't change anything. So I do k into brackets, k plus 1 divided by 2, and then I have plus, I write this down again, k plus 1 is equal to k plus 1 k plus 1 plus 1 divided by 2. I don't have space here, so we continue. I will clean this place and then we continue again with to complete whether we want to show whether this side is equal to this side. So what I've done so far is don't forget, we have proved that the base case n is equal to 1 is true. We just made an assumption that n is equal to k. So that gave us this expression. And now I am at n is equal to k plus 1. I want to show that when n is equal to k plus 1, this expression or this equation holds. So what I've done is to replace all the n by k plus 1. I did 1 plus 2 up to k and then plus k plus 1, because after k then comes k plus 1 is equal to, and then we have this now. Now we know that when n is equal to k, this expression here is equal to this expression that I have here. So this here we can replace by this. When we replace by this, we now continue to resolve ours to see whether this will give us an equal, the left hand side will be equal to the right hand side, if it will. Then we have plus k plus 1, this one, I move this one here, is equal to this is equal to k plus 1, and then we have k plus 2 divided by 2. Now I want to remove the 2 from the denominator 2 from the equation, so that we have no denominator. So I multiply each term by 2. So if I multiply this by 2, I get k into brackets k plus 1. I have to multiply this by 2, so I have plus 2 into brackets k plus 1, which is equal to, multiplying this by 2 takes this 2 away, so I have k plus 1 and then k plus 2. Now when if I look at this here, I see that this and this are common to this term, so I can just factor it out, k plus 1, yes, and now I'm left with k plus 2. And indeed, the left hand side is equal to the right hand side. They are the same. This and this are the same. So it's true. So this is how to prove by induction. First, as I said, you do for when it's true for n is equal to 1, and then you make an assumption, that is an induction hypothesis of this, and then you go on to show that n is equal to k plus 1 is also true. Thank you for watching. Please don't forget to subscribe to my channel for more videos. Thank you. Bye.